Hello, everyone, and welcome to our webinar, Building with Google's new Open Gemma Models. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars. We do 2 per week, and we demo new data and AI use cases, and also new tools and technologies. I post about these upcoming webinars every week. So if these topics are interesting to you, feel free to connect with me on LinkedIn. I'd also love to hear your feedback on these sessions and also any ideas that you would like to see in future sessions. Speaking of future sessions, on Wednesday, Akmal here is going to be presenting another workshop, GPT workshop, Build Fraud Detection App using OpenAI. You can come and watch the demo that he's working on. I think he's made a lot of progress already, and check out his code share. It's going to be a really fun session on combating financial fraud. OpenAI and Kafka, I think, are among the tools being used. Maybe he can talk a bit more about this in a second. If this is interesting to you, check out that short link. I'm going to put that in the chat in a minute, or you can just take a QR code photo of that QR code or screenshot of that right now, and that'll take you to the same place to register. Get your seat. I hope to see you on Wednesday. Back to today's topic. We would love for everyone to participate in this discussion throughout the session. There is a Q&A button at the bottom of your Zoom console. Just click that, type in your question. We will answer as many questions as they come in. We'll also have a live session where we talk about the questions at the end of today's presentation and demo. We have a mission statement to try to answer 100% of audience questions, even if we have to email you afterwards if we don't have time to get to your question during the session. But you have to include your name and email address when you're asking those questions. We will not be answering any anonymous questions. We'd also love for you to try out the technology that we're showing today. In fact, anyone who tries it today will be entered for a chance to win brand new AirPods Pros. There's a short link on your screen. You can just visit that link. I'll put it in the chat in a minute as well. You can take a photo of the QR code as well. It's super easy. Just visit that link and log in. You may know that SingleStore has had a free trial for a long time now, but recently we also announced a completely free shared tier. We can talk a little bit more about that, but it's never been easier to try out SingleStore. Just log in, and if you log in through that link, you will be entered for the AirPods raffle. Winner will be announced within the next 45, 50 minutes or so here in the session. Let me introduce our speakers. Akmal is a senior technical evangelist at SingleStore, strong expertise in big data, machine learning, and AI. He's a regular speaker at our weekly webinars here. And then we also have Ayush Pai, who is a computer science student at Georgia Tech. I found him online after he made several viral AI demos, which are really cool. Since then, we've partnered with him on a few projects that demonstrate the power of SingleStore for AI. Akmal, I'll hand it over to you. I think you have the floor first.
Right. Well, thank you very much, Matt. And thank you all for joining today. Good afternoon, good morning, good evening, wherever you are in the world. Thank you very much. Again, we appreciate your time. We know your time is valuable, and we do try to make these sessions as interesting and as relevant to you as possible. So normally, for those of you who are regulars and attend this, you'll know that typically right about now, I look at my phone here. Normally it's 6 p.m. London time. Today it's strange because it's 5. So daylight savings time somewhere has changed. North America, I suspect. Okay, so as you know, in the United Kingdom, our time changes. I think it's the last Sunday of October and the last Sunday of March. So we've got a couple of weeks before that changes. But Matt will share those links to the AirPods drawer and the webinar. This one, let me just try and oh, apologies, the key's a little bit stuck there, not letting me go back. But anyway, the one that he mentioned just a few moments ago, this is on fraud detection. So about a year ago, Matt and I did a webinar. I think it was one of the first ones we did looking at OpenAI and GenAI in general, and it was quite a popular one. And at that time, I looked at 3 technologies: scikit-learn, Apache Spark, and OpenAI. and I evaluated some data that I had representing, fraudulent transactions in banking. And I tested these three technologies, and Spark and scikit-learn came out quite well. They did pretty good detection rates, and OpenAI was terrible. And then we kind of concluded that maybe it wasn't, prime time, wasn't ready, and we'll wait. And it's been about a year now, and I tried it again today, as Matt was saying, and unfortunately, it's got no better. Okay, sorry to give away the big secret, but anyway, I attend on Wednesday, and thank you, Matt, for reminding me. I had the feeling in my mind that somehow it might be Thursday, but I'm glad you told me. So we'll go through that again. And one of the cool things is that, of course, since that time, we now have our own notebook environment. And so I've been just experimenting and installing Apache Spark in our notebook environment, and it works fabulously. Okay, so please attend, and we'll learn all about that. Okay, so today, my 2 slides, and then I'll hand over to Ayush for the meat of the presentation. So SingleStore DB, we often get asked about this. So historically, very much focusing around data management and OLTP, keeping things in memory super fast, and then subsequently adding columnar storage for analytics. So doing these operations, some min, max, average, count, at scale, and then really adding a whole range of additional capabilities as well, what we term as multi-model. So we'll look at that in just a moment. So here is the kind of the big picture, okay? What I guess you could term as the 30,000-foot view. And with this universal storage that can handle both OLTP and OLAP data, and then fast ingest from a variety of technologies. So we've covered Kafka quite frequently. As I mentioned before, Spark, I think the last time we did it in the webinar was a year ago, and we're going to look at it again this week. And there's other things like S3, for example, or Hadoop HDFS, if you're working with those. And then I think the animation here is designed to show that you can really read this data from these sources in parallel, in bulk, at speed. And that's really a great capability. Okay, so we are available on the major cloud platforms, okay? AWS, Google Cloud, Microsoft Azure. I believe today we are going to be using AWS, or Ayush will be anyway, hopefully. Can run on-prem, okay? That's possible too. And there's a Docker container as well if you want to try it out. But seriously, follow the link that Matt has shared. Create your account. If you don't have one already, it's like less than a minute of your time. Just put your details in, hit the click the button, and you'll get your environment and the free tier, $600 worth of credits as well. And additionally, within that portal, you can have access to a license that will allow you to install your own version of SingleStore anywhere you want, okay, on-prem, in the cloud, wherever you want, 4 nodes, fully functional database system, exactly the same as you get in the cloud, only it's restricted in terms of the number of nodes, right? But the quickest and easiest way to start is through the web portal, okay, because there's nothing to install locally. All this good stuff that we've talked about in many webinars in the past. So yes, we are very much based around relational technology, but we can do other things as well, geospatial, time series, key value, okay? JSON support has always been there. It's got even better with SingleStore Kai now, which is the MongoDB compatibility. That's GA, and lots of cool stuff being added there as well. Expect some interesting webinars over the next month or 2 on that as well. My colleague Vijay and others will be presenting on that. And of course, vectors, so the hot topic of the day, okay? So that is very popular these days, and everybody's got a vector database now. Key thing here is that, remember, an FYI that SingleStore has vector support for a long time, okay? Since 2017. And we've got some really cool stuff we've introduced this year, a dedicated vector type, support for approximate nearest neighbor search, lots and lots of indexing techniques. There's just way too much to cover in this presentation, and I don't want to eat into the time because Ayush has got always some awesome stuff to discuss. And then just to wrap up then, so real-time decisions, IoT, dynamic experiences, dashboards, plug in your favorite tools, Tableau, whatever you like. I use, Metabase simply because it's free. It's just a jar file, download it, and can have visualizations created minutes. Ad hoc queries as well. There's a built-in SQL editor in the cloud-based environment. And of course, lots of great machine learning capabilities with the notebooks that we provide as well. So we are a data platform now, okay? And so it's much more than just the relational technology with all these additional tools that we provide through the portal. And with that, I will now hand over to Ayush, okay? And let me stop this and stop the share. So he will take over now. There we go.
Awesome.
And so I'll drop down and answer the question. So over to you, Ayush.
Sounds good. Let me just share my screen really quickly. Awesome. Can you see this?
Yeah, it looks good.
Yeah,
Okay,
looks
cool.
good, Ayush. Looks great.
Awesome. All right. Thank you, Akmal, for that great introduction. So welcome, everyone. Thank you for joining today's webinar. Again, I'm Ayush Pai, and I'm a computer science student at Georgia Tech. And today we'll be discussing building with Google's new open models, specifically Gemma. And generative AI is kind of like a fascinating field, right? It's really rapidly evolving, and at its core, it involves artificial intelligence systems that are capable of creating content across various mediums, such as text, images, music, and more. And this is a very hot field, as you know, if you've used ChatGPT or any of these large language models. They're very helpful in a lot of ways. But the biggest thing about these models are a lot of times they're kind of closed behind doors. ChatGPT, GPT-4, some of these bigger models, we do not have access to them, to the training weights, the training data set, stuff like that. And a big movement during the generative AI movement right now is moving towards open source and open models, right? And this really democratizes access for just, your regular developer to kind of fine tune towards, specific use cases. The biggest thing about large language models today is that we have these models to train the base model. Takes a lot of resources, takes, thousands of GPUs, a lot of compute power that your developer, your average developer is not going to have access to, but only the largest companies in the world, such as Google, OpenAI, Meta, will have access to. So just continuing a little bit more about generative AI before we move on, these models really analyze patterns, styles, and features from their training data, and they really utilize complex neural network architectures to understand and recreate data structures in novel ways. It's not just a duplication process, it's really akin to how artists and learn from predecessors and then goes on to create their own works, or authors take inspiration from texts that they read, etc. So moving on to large language models themselves, right? At their core, LLMs such as Gemini, GPT, Claude, Llama, Mistral, they all aim to generate human-like text responses from user queries. They're built on a transformer architecture, which is a revolutionary for its self-attention mechanism. And this allows the model to weigh the importance of each word in a sentence, no matter its position, right? Kind of ensures a coherent and contextually relevant response in all scenarios. And what really sets these models apart, especially decoder-based ones such as GPT, and their streamlining structure that really learns directly from input to output without separate encoding space, right? This direct mapping from an input text to a generator output really enables a really fluent natural language generation process. The power of the real power of LLMs kind of lies in the training process itself, right? This kind of involves, unsupervised learning from massive data sets. A lot of these models are trained on the entirety of the internet. They predict the next word in a sequence by kind of absorbing patterns from like a vast corpus of text data. The training does not require, labeled data sets, which are often costly and very time consuming. And you know, open source models kind of really democratize access to this technology, allows researchers and developers, even hobbyists, to contribute to and experiment with these, LLMs and deploy them in various applications. Then it kind of like prevents, only a couple companies from having access to this technology. And as we dive deeper into today's session, we'll kind of explore, the potential of these open source LLMs, open source versus open models, which we'll talk about a little bit, and explore specifically how we can build with Gemma. So starting off with Google's models, right? So a little bit of history about what Google has released in terms of their Gemini lineup. So starting off with the Gemini Nano, this model is kind of tailored specifically for mobile devices. They kind of bring sophisticated capabilities of LLMs directly into the palms of users. They have a direct toolkit with Android development, and this really allows for powerful on-device natural language processing, really opening up the possibilities for offline applications. And just to clarify, right, all these models currently, the Nano, Pro, and Ultra, these are closed source models that Gemini, specifically Google Gemini offers. And next in line, we have Google Gemini Pro, and version 1.0 was kind of released in December 6th, 2023. And it was kind of, targeted as a direct competitor to GPT 3.5. Then they came out with a new, more efficient V1.5 on February 15, 2024. And this kind of boasts, a quality on the par of the original Ultra version, which is their flagship model, but requires significantly less computational power. And additionally, it has their 1 million context window, and it's a really great model. This represents, a considerable advancement in efficiency, which is really crucial for sustainable AI development. And kind of the crown jewel of this series is the Google Gemini Ultra, their flagship model, released on December 6, 2023, and kind of sets the standard for scalability, designed to handle, diverse array of tasks with exceptional performance. And these are the models that Google have that are, closed source. You can access them with an endpoint or an API, but you can't directly access the weights. So just a little bit about open versus open source models, right? So in the rapidly evolving landscape of artificial intelligence, it's kind of important to make this distinguishing between these open source models and open models, right? So open source LLMs like Llama 2, Mistral 7 billion parameters, they're not just accessible, they're kind of like a communal resource where their training weights can be downloaded by anyone. It's kind of a feature that encourages transparency, kind of fosters collaborative advancements in AI. A lot more research paper gets published. And open source models kind of embody the ethos of sharing knowledge, allowing researchers and developers to build upon them, and just improving the AI community as a whole by giving everyone access to these training weights. It really ensures the mission of this is kind of to ensure the progress of AI benefits the wider community, such as you and I, right? We're just developers or just hobbyists, and we would like to contribute or look at the weights or fine tune these models in any way. That's what these open source LLMs kind of do. On the other hand, you have open models, right? And open models are a very similar concept to open source models. They provide free access to the model weights, but with certain limitations, right? These models come with terms of use that might restrict how they might be modified, shared, or commercialized. And while they're available for use, they don't offer like the same level of freedom of open source. And this is kind of like a message from Google. They said as that we kind of adopt AI more broadly, it's kind of vital to understand these differences, right? The open source movement has been a really great driver innovation over like the last 20 years. In AI and other fields, right? But as we apply these principles to AI, we must kind of navigate, the challenges such as defining derived work, and ensuring proper author attribution. So Google's approach with Gemma kind of stretches the need to adapt open source concepts for AI while also maintaining the foundational open principles, kind of adhering to unique aspects of AI systems. And this will really ensure AI's transformative power is harnessed ethically and responsibly. But either way, open versus open source, we're still getting access to the weights. It's still better than closed source models such as GPT-4 that we can't really access without an API directly from them. So moving on, just as an overview of Google Gemma. So Google Gemma kind of represents a significant stride in the domain of AI, where it's a suite of open models which are like kind of like a product of the same pioneering research and technology that kind of fueled the development of Gemini products. Gemini models by Google DeepMind, and they're kind of lightweight and kind of cutting edge, right? They have two of these models currently out. They have Gemma 2 billion and they have Gemma 7 billion. These variants come with pre-trained and fine-tuned for specific instructions, but provide the developers tools kind of right out of the box to train these models and fine-tune them on their own data sets. So the optimization of Gemma is that they have kind of like a collaborative effort. They have like a collaboration with NVIDIA. The partnership kind of leverages Gemma for NVIDIA GPUs, really enhancing the model across various platforms, data centers, etc. And Google has kind of placed a strong emphasis on responsible AI development. Gemma is kind of accompanied by responsible generative AI toolkit, which kind of reflects a commitment to ethical AI practices and overall like the whole open source movement. And it's great that Google and Meta or all these companies are releasing these open models, kind of just democratizes access. And even with the responsible generative AI toolkit, we can make some standards that even with these open models we can have good standards. So kind of looking at the Gemma benchmarks, comparing them to some of the other open models that we have access to. So this kind of showcases the impressive abilities of Google's Gemini 7 billion model, especially the MMLU metric, which achieves 64.3 success rate. This notably kind of outperforms Llama 2's 13 billion model, which is 6 billion more parameters than Gemma, and it kind of almost by 10%, right? So Gemma was trained with 6 billion less parameters, and it was able to outscore it by 10%. It kind of underscores, Gemma's really efficiency and sophistication. And in a detailed comparison across various benchmarks, Gemma 7 billion kind of consistently leads or kind of remains competitive. Signifying its adeptness, its attention to detail, and their training data sets and their training parameters. So, for instance, in the HelloSwag and the PCA and the, I believe, BullQ benchmarks, Gemma kind of scores really notably high. Just shy in BullQ, Gemma is kind of just shy of Mistral's 83%. And this is kind of like measuring advanced reasoning abilities, stuff like that. So, and these benchmarks are taken directly from the Google Gemma's technical report. You can check it out from there later if you want to, but they kind of represent how these models, as they keep getting released, they kind of, try to one up each other. And it's really not just like a competitive thing, but it's kind of like, increasing, the whole developer AI community's access to better and better models, right? And eventually we'll have a model that's as good as GPT-4, as good as whatever comes out when the closed source, right? We're not going to have access directly to like the most state-of-the-art models as open source, but eventually we'll get there as these open source models kind of compete with each other. So building with Google Gemma, so there's a lot of things that you can do with an open source model, right? So one of the main things that come to mind is customizing the model's behavior, really training it for a particular application by training it on a data set that's kind of suit to your needs, right? So if you want to train a model that knows everything about football or something like that, or basketball, some random topic, or like finances, taxes, whatever like random topic that you have, you want to train this model on, you would have to have a data set with that. Those are the parameters, and then you put them in, you fine tune it towards this, and then you can improve this model that can be directly suited towards your needs. You can also do retrieval augmented generation, which is RAG, and combine the power of large language models with external knowledge bases. And you can do this all completely locally. You don't have to be using an API and accessing it directly from OpenAI or Google. You can just be running this model locally on your computer and doing a vector search on a vector DB such as SingleStore, and get this information for RAG. And we'll talk a little bit more about RAG later. And you can also create interactive AI applications. So you can use these open source models to develop interactive applications such as chatbots, virtual assistants, advanced text analysis tools directly for your company or for your clients. Specifically, we have a lot of companies today who are actually looking for large language model solutions as an internal tool for their employees or as an external tool for their customers. And a lot of the times, the cost accumulated with using these open source or these closed source models rather from OpenAI or Google is very hefty. And using these closed source or using these open source models will allow them to fine tune them further towards their specific needs, and also have direct access without calling an API every time. They can have it locally, or they can have it within their own cloud services, stuff like that. They don't have to rely on another company's API, which comes with a cost as well. So kind of getting started with Google Gemma here. So we have three primary platforms where we can access the model currently. So we can access it on the Google Vertex AI platform, which allows you to customize Gemma models with your own data deployed to applications and kind of scale with ML ops built in. We have Kaggle, which is a great platform. They have a lot of models there, and you can use Gemma models directly there. Google has a partnership with them, and they have all the models directly there, and you can use them in any popular frameworks that you want. And you can also access them directly through Hugging Face, another really popular platform, and you can access, fine tune, and deploy Gemma models with Hugging Face. Transformers they have their Transformers module. PFT, and you have text generation inference libraries. These are great ways to access it, and Kaggle and Hugging Face are kind of especially Hugging Face. It's kind of like kind of one of the pioneers in this open source movement, and it's great that they have a great collaboration there where you can access the models. So kind of continuing on this end, right? So getting started with Gemma here. This kind of demonstration here that with this code is kind of showing how you can use Gemma with Hugging Face's Transformers module, right? So in this example, we're using the Gemma 7 billion model from Google's with Hugging Face. So essentially, first you need to ensure that you have the Hugging Face library installed. So that's just pip install with that Transformers library there. And so the next step is to import the necessary modules. So we have the auto tokenizer module. And a pipeline which is kind of like a pipeline from the Transformers package. And then we also have, importing Torch if you want to plan to use it on a GPU, importing PyTorch so we can get that model GPU optimizations. And so then we have, setting up the model is kind of simple, right? We just assign 7 billion to Gemini 7 billion to a variable. Then you kind of initialize the tokenizer with the auto tokenizer from pre-trained method, and then essentially from there the tokenizer kind of prepares your output text for the model, and all this this is directly running it through Hugging Face's auto tokenizer, and it's using your own GPUs to kind of optimize that process there. As you can see, you can have the pipeline set up where you can use you can say what you're doing. So we're doing text generation here. We have the model, setting it to the Gemma 7 billion. We have some stuff about like the Torch parameters for specifically what parameters you're using for the GPU, and device using CUDA. We have the messages here, so we can specify. This is just pretty standard about a lot of large language models. You kind of specify the roles, user, content, stuff like that. And here we're saying kind of just, this is an example, who are you? And then you kind of apply this pipeline to this template where you put in the messages, and essentially from there, you can just generate the outputs. You can with the pipeline that you just made, and what you're doing is you're kind of setting your prompt. You're setting your max tokens, and kind of a bunch more parameters here: temperature, top K, top P, all standard parameters, hyperparameters when you're generating outputs for a lot of these large language models have the kind of the same similar parameters. And then you print out the output, right? We have an example of this later on in the demo, a live example when we go through the code walkthrough, but this is kind of like the general process of just starting off with the Gemma 7 billion with the Hugging Face Transformers library. So you can also integrate with Google Cloud directly. So this is a big thing with Vertex AI, right? You can deploy and train Gemma on Google Cloud through Vertex AI or Google Codernauts engine. And you can directly use the text generation inference or transformers from there. And this is a great platform. You can you can choose which development environment you can use, fully managed platform with Vertex CI or GCK or GKE, and you can choose the deployment model. You can do 7 billion, 2 billion, some more parameters here, the region you want to do it in, and stuff like that. And you can kind of deploy it from there. That allows you to run it directly in the cloud. So that's something you're interested in. But kind of like now going into some of the more unique factors about allowing you to have these access to these open source weights, right? So one of the biggest things that people do with open source models and open models in general are kind of like fine tuning them for specific use cases, right? So what we're going to be doing for fine tuning is there's a library called TRL. And essentially fine tuning transformer large language models like those offered by Hugging Face has been elevated to like a new level of precision and customizability with the introduction of Hugging Face's TRL, which stands for Transformers. So I forgot the L, sorry, but learning. I think just it's a great library by Hugging Face. Forgot the exact acronym there, but this specialized library kind of really harnesses the power of like reinforcement learning techniques to kind of sharpen the model and sharpen the performance of the model. Using these reinforcement learning techniques, and Hugging Face TRL kind of really goes into like it's kind of like a sophisticated wrapper around like the established transformers trainer that we already saw, right? The synergy kind of provides like a nuanced approach for fine tuning on custom data sets that allow the greater base model that you're using to kind of adapt to specific tasks or domains. It's a really great way to it's a really easy way to fine tune your models. It's a great platform by Hugging Face. It's kind of the first step here is to install the TRL library to access the training script, right? So we install the library, and then you want to git clone the training script from the Hugging Face GitHub. And so here's kind of like the training script itself. And so these are kind of like the parameters, right? We have the model name, we have the dataset name, the batch size, we have gradient accumulation steps. These are very important hyperparameters when training your model. And just kind of going into like the more, some of like the more notable ones, right? So we have essentially we have a lot of these parameters, right? But so what do some of these parameters mean, right? So I kind of chose like 4 of them right here that are kind of like important parameters that to kind of like understand. So first of all, we have like the model name, which is, we have Gemma 7 billion. Then we have the learning rate, which is set to 2 to the 10 times -4, I believe. And essentially for this, essentially this kind of is a small value that allows you to kind of gradually, and make precise adjustments to like the model's weights during training. And this is the learning rate that it goes at. There's a lot of research papers around setting the correct learning rate based on your specific use cases. But this is kind of like a delicate balance between too high of learning rate might cause the model to overshoot the optimal weights, but too low of a learning rate kind of might cause like too long of training time or get stuck in the local minima, stuff like that. So the save steps parameter is kind of set to 20,000. And this kind of indicates the model's state will be saved after every 20,000 steps of training. This again is like a lot of research goes into how to optimize these hyperparameters for the best possible results. But this is particularly useful to kind of safeguard the training process, kind of allowing for recovery, without starting from scratch. And a lot of cases when you have GPU interrupts, which is kind of a problem, a lot of times if you're doing like cloud compute GPU, stuff like that. It's when you're dealing with these extensive training sessions, it's important to have the save steps parameter. So the next thing is kind of like the script. So the script kind of provides like likely accompanies. It kind of has a command line tool that initiates these fine-tuning process steps. So you have you can have a distributed training setup to accelerate the learning process. This setup is kind of reflected by arguments that distribute the workload across multiple GPUs. So these parameters kind of like show how you can change your fine-tuning process. Again, there's a lot of research that goes into, fine-tuning these parameters, but definitely really helps if you have the right parameters when training and fine-tuning your own model. So now here we can go into a little bit of a demo with SingleStore, DB, and Gemma. So how we can build a RAG application using this open source model locally and using SingleStore DB as our vector database to access our, during the retrieval augmented generation process, access our documents, right? So kind of like just an introduction to what RAG is, right? So retrieval augmented generation kind of integrates the generative power of LLMs with the retrieval mechanism, right? So this allows the model to query a curated database for, contextually relevant context, and kind of before generating a response, it kind of merges this vast knowledge from a specific document that it finds with, with the vastness of this, huge LLM to actually, curate a good response. So what it's doing essentially is it's taking in this, it's taking in your user query. It's, putting it through a vector search capability, something like SingleStore as a vector database to search for the most relevant documents. Once it finds the most relevant documents to that specific query, it's going to return that document back to you. And then you're going to feed that directly into the LLM in a combination with the query itself. So that will give the LLM their context that it needs to answer the question without hallucinations or making up a response. Which if you use ChatGPT or a lot of these large language models, a lot of times they have responses that kind of seem made up, but they seem very confident still. They seem very confident with their answer, but they're not accurate, right? That's a big problem, and that's kind of what RAG tries to solve here by giving context to a specific query. So delving deeper into the retrieval augmented generation framework, the retrieval step is kind of like the blend of the database efficiency, which meets the sophistication of large language models, right? And documents are kind of transformed into dense vector representations. This kind of uses embeddings that encapsulate their semantic content. And these vectors are stored in a specialized vector database, such as SingleStore DB, which is renowned for its retrieval efficiency, obviously. And we have, when a query arrives, it's kind of similarly converted to a vector using the same embedding process, right? So a vector search is then like kind of executed against the database to identify the documents whose vector representations closely match the query vector from the user. And this is kind of a nuanced operation where it leverages the geometry of high-dimensional space to kind of find matches based on semantic similarity rather than keyword overlap or more subpar techniques, right? This system prioritizes documents based on relevance scores, and it really is a function of the vector similarity to the query. And I'm sure Akmal or Matt can really talk more about like specific techniques that SingleStore DB is using to make it really efficient, but it's a great platform to use this vector DB to kind of power your LLM applications, right? So kind of like a technology overview for a demo here. So we're going to be using LangChain to kind of pre-process the formats, and kind of format the text data, making it suitable for embedding generation. We're going to be using Vertex AI embeddings to kind of generate vectorized forms of the documents. SingleStore DB to kind of store the prepared embeddings in a vector database. And we're going to be using the Gemma Open model to take in user prompts, and plus the context that is got from our SingleStore DB vector database once we do the retrieval step. So we kind of combine the prompt and the text, the prompt and the context, and from the retrieval step, and then generates the output based on that combined query. And we're going to be using Hugging Face to load the Gemma model with the transformers auto tokenizer that we kind of talked about a little bit earlier. So kind of an overview of LangChain, right? So LangChain streamlines the text pre-processing for embedding generation, essentially enhances the input for NLP models. Instead of just putting in, a PDF that might be just full of, encodings, stuff like that, or even a text file that's not very formatted well. It's not split into relevant documents, stuff like that. All this stuff can really unoptimize your RAG system if you don't have something that kind of goes in and streamlines the pre-processing, right? And makes the text suitable for retrieval augmented generation process. And so what we're doing is we're utilizing the PyPDF loader to load and read content from a PDF file. So this kind of employs the recursive character text splitter to divide the document into manageable chunks of 2,000 characters without an overlap. So there's a bunch of different, they have the recursive character splitter, they have their character text splitter. It provides a great, really easy, efficient way to kind of, chunk your documents and prepare them for embedding. So essentially now we have the next step, which is embedding generation, right? So we have our documents in plain English. And plain English is great, right? But it's not going to be suitable for a vector search or something where we need to quickly retrieve the documents that we need that are relevant to what we're doing. So Vertex, so there's many different platforms that you can use for this specific example. We're going to be using Vertex AI since we're doing already stuff with a lot of the Google models. So Vertex AI embeddings generation leverages, advanced language models to kind of transform the text into high-dimensional vectors, essentially kind of, taking your text and, using the semantic relationships between the letters and the words to generate these texts, which are kind of, to the human eye is gibberish, but to, any similarity search algorithms, it's, much more useful comparing numbers instead of, these vectors instead of, comparing, characters, right? It converts, pre-processed text chunks into embeddings, which are kind of lists of floating point numbers. Each number kind of captures the aspects of the text, semantic and syntactic characteristics, try to best represent, a character and the semantic understanding as well. So we have these embeddings that encapsulate the meaning, context, and nuances of the text, allowing us to really process and, have the natural language more effectively, represented within these vectors. So now I'm just talking a little bit about SingleStore DB as our vector database here. It's kind of like the heart of the application here, of our application, right? So we have, we anchor all the embeddings in SingleStore DB, which is a robust SQL database that is designed for, high-speed vector data operations. So the connection to the SingleStore DB allows us to leverage its high-performance capabilities to store and query our pre-generated embeddings from whichever embedding model that we choose to use, in this case, Vertex AI. So with SingleStore DB's from documents function, we can create a vector database that pairs with documents with the respective embeddings. This pairing is kind of stored in a structured table that is meticulously designed for swift retrieval and efficient storage. This is a crucial process for handling large volumes of data, right? So the crux of RAG's functionality lies in the query-based retrieval, which is really adeptly handled by SingleStore DB's similarity search function. And when a query is kind of issued, the system performs a vector similarity search to find the most relevant documents. And this process relies on the embedding's ability to capture semantic meaning, allowing the database to quickly return documents with a high degree of relevance, and using techniques such as ANN, cosine similarity, etc. And the setup of the streamlines, this setup not only kind of streamlines the retrieval of this really important information for our large language model, but can also optimizes the RAG model's ability to kind of generate accurate and contextually relevant responses. And by integrating SingleStore DB as our vector database, we can kind of ensure that the RAG model can retrieve and utilize the most relevant information. And here's kind of like a look at what the SingleStore DB looks like. You can see we have our table here. We have the content itself. This is specifically for a Super Bowl example. We are vector, which is kind of gibberish here, but again, it's super well represented for if you're doing vector searches, and kind of the metadata of where exactly we got it from, kind of the source of the document itself, and that's kind of the table that gets created there. And so kind of understanding how we're loading, our combined prompt plus text into the Gemma model, kind of bringing it all together in the RAG process. So we have, we're doing our import statement again from the auto tokenizer, kind of getting these modules back in. And essentially, what we're going to be doing here is we create this auto tokenizer that loads in the Google Gemma model, 2 billion parameters, and essentially what we're doing is this auto model automatically creates this model representation that we could use locally, and essentially from this we can uses these pre-trained weights from Google's Gemma 2 billion. And the device map you can set it to torch on. This is where you can do specific things with your GPU. We're setting it to the auto device, and essentially what you do is you move the tensors to the GPU and you generate a response. So you'd use the tokenizer that you just created to take in the combined information, which is our context plus query, and this is this is the user input plus the context we get from SingleStore DB. Then we have the tensors that we're returning, and we're using .2 CUDA, which is essentially just saying to the what we're using is our GPU, right? We're using CUDA, which is NVIDIA's framework for GPU optimizations. And essentially, we create a response, which is just model.generate, and we just, we have our input IDs, which is kind of like the tokenizer with the combined information and information about the GPU, and we have the max tokens that it needs to generate. And then we just print out a response. And this is a great way. Now we don't have to, do a call to OpenAI. Now we don't have to do anything like that. It's all completely local using your own GPU and the weights from Google, and you can just directly run it here. No need to, make any API calls that are very expensive. And yeah, so now we can go through like a quick code walkthrough and demo, and then we can get into questions. So let me just open up the code demo. I see. Okay, cool. So this is kind of the notebook that we'll be using today. So you should all have access to this eventually after the demo. And essentially, right, we have, this is just, kind of housekeeping here, setting up some things for the Google Colab notebook. We're just in this cell right here, we're just checking if we have access to the GPU. Just if you haven't used Colab before, and again, you can run this without a GPU. You don't even have to run this on Colab or anything. You can run this completely locally on your computer, and you don't need any, just maybe an ID or something. But essentially, you can run it on your CPU. But in this case, we're using a GPU. It's a lot faster if you have access to one. And if you haven't used Colab before, you would go to change run type, and you have access to all these different GPUs. Currently using the T4, but A100 is the flagship. You can use any of these as you want. Essentially, right, this is kind of like checking on the GPU information. We're using the Tesla T4. And yeah, so this is kind of the process where we go through and install like the libraries that we need for this initial setup. Essentially, main thing we're using here from this is the sentence transformers, and just transforms in general. We don't really need PyMongo or pandas or data sets right now. So these are just the main things that we need. And Accelerate is used to, if you're using a GPU, it's a platform for that. So then we have kind of like the process where we kind of set up the Hugging Face models. So the transformers is from Hugging Face. We get the auto tokenizer. We have the auto model for casual LLM, and so this is just me just setting up the token. This token you need to get from your Hugging Face. From Hugging Face, you need to go to Hugging Face and go to your profile and essentially just set up your token from there. And you would just have this login with your token. And this is just an example code for running the Gemma 2 billion parameter model. So essentially what we're doing again is they're setting up your tokenizer where we have this model, which is, created from the weights, and we have the device, which is set to auto, and we have our input text, input ID. This is just a simple prompt to write me a poem about machine learning, no RAG or anything like that, just a simple prompt just to see how it works. We're using .2 CUDA to optimize using our GPU. And here we're setting the max tokens to 500, and let's see what it's able to do. So this is kind of like running its, checkpoint shards, and it's setting up anything with the model. The first time you run this, it might take a little bit longer to set up everything directly locally on your computer. This should, um, yeah, this should take a few seconds here. Not sure. Okay, I think my session got reset. I'll just reset from the top. So just run all these cells. Yeah. Okay. And obviously you can also run through all this as well. Once you have access to this, notebook, but now it's running the cell again, and hopefully it should be good now. Everything is already satisfied. Not sure why this is happening, but okay, it's okay. We can come back to this later. The tokenizer, there's some issue about like one of the libraries is not defined, but I think I might have accidentally actually deleted it here. Okay, it's okay. We can come back to it in a little bit. But essentially, right, that's just as a process for running that. And you just have to reset your Colab environment and run it again. I think after a while it kind of resets. But essentially, right, we have this process here, which is this is where you can use Google's Vertex AI text embedding library. Essentially, here you can kind of see a lot of stuff about setting up your project. So this is your project ID. This is from GCP, Google Cloud Platform. You can have access to a lot of these, different models from GCP and Google Vertex AI. But essentially here we can create a text embedding. We have the model name, and the model name here is text embeddings Gecko. And this is where, we're the text embedding models again is where we take our text, convert it to vectors, and that's where it can be super quickly accessed through a vector database, through vector similarity searches. And here's like a process where we're kind of creating this all together here. So we have our, link chain libraries that kind of help us kind of load the data. So we have this PDF file called superbowl.pdf. I like to use Super Bowl example a lot when we're dealing with RAG because it's a pretty recent event, maybe only a month ago. A lot of these models have been trained, way past before that, right? Training the base model only happens once every, 5-6 months for a lot of these companies. It's a very, very expensive process. And the reason why I'm testing this out is because recent events are not going to be included in that model. If they're training on the internet, the Super Bowl and anything in the last month or so, it won't be included as in the training parameters of the model. So trying to use a recent event, such as the Super Bowl, kind of demonstrates the process that, hey, okay, it's working based on, stuff that's it's not been trained on already. And yeah, so in this case, we're using embeddings, and essentially what we're doing is we're creating a SingleStore DB document, which we're taking our embeddings, we're taking the text and the embeddings and creating a table. Kind of showed how that table looked like back in the slides. We have our user query, which is who won the Super Bowl. You can do anything you want here. We perform the similarity search, and essentially we just check if the document exists, and if it does, which essentially what it's doing is checking if the document exists, because the query could be nothing related to the Super Bowl, right? It could be something, it can be asking about like something completely random, and that document that query might not be in the vector database that we're looking for. And so that's why it's very important to look specifically for the documents that you need. If it doesn't find anything, we'll say, could not find relevant information here. But here's the output I was able to do. You can run this yourself if you. I think you only need like a T4, and this is you can run this with the free Google Colab. You can run this environment directly here. But yeah, essentially what it's doing is it's using the auto tokenizers, creating our model here, combining the information from the user query and the context, and so it takes in the user query, which is from here, who won the Super Bowl, and then saying the context is directly from our documents, which is from our similarity search from the SingleStore vector database. And then we combine the information, we put them into our input, and then we generate the response based on that. And yeah, I think we can start with questions, Matt.
Awesome. Yeah, I think we'll have time for one or two live, but keep the questions coming. Like I said at the intro, we're going to answer 100% of questions, even if we need to do some via email. And so maybe one or two questions before we do the AirPods winner. I see one unanswered right now. Question: can we fine tune a model twice? First, I'm fine tuning with domain specific knowledge, and then can we fine tune that again, that trained model with conversational data?
Yeah, it's definitely possible to fine tune twice, right? So you would take the weights from the first time you train it, and then train it further on that specific weights that you have now. The fine tuning process is essentially just taking any data set that you have and getting new weights based on that, right? You have your original weights from whatever open model you're using. You'd fine tune it and you'd get your new weights that are fine tuned to your specific use case, and then you can take those weights again and fine tune it any way possible. There definitely have been demonstrations where people have done that and it's been successful.
Awesome. I see another one here. Can you please explain more fine tuning the Gemma models using LoRa or Dora?
Yeah. So I'm not sure too much. Akmal, do you want to try to take that one?
Sorry, I'm not familiar with Laura or Dora. Are they twins? So what?
All good. We can look into that one and follow
We'll
up with
look into
that.
that. I mean, it kind of shows the limitations of our knowledge. I mean, yeah, we don't know everything, but awesome question. Yeah, we'll find out.
Yeah. Okay. And Akmal, I know you've been answering furiously during this session. Any
Yeah.
ones that are either outstanding or good questions that you wanted to pose to Ayush?
Oh, okay. I think the one question I saw a couple of times, or variations of, is SingleStore versus other vector databases like Pinecone or ChromaDB. And so the key thing is, for those of you who attended right at the beginning, you see that I showed the slide with all of the kind of components, you like the 30,000-foot view of SingleStore. So it is an enterprise product. It does a lot more. That's the one, yes. It does a lot more than just vectors. I mean, vectors is just one part of the solution. And so if you think about it, in an enterprise environment, typically you're going to have a wide range of use cases and people wanting to do lots of different things. I mean, vectors are just one small problem to look at, and great for use with LLMs, and people are exploring that and figuring out ways to make it beneficial in the business environment. But until that time, I mean, something like SingleStore is going to be much more useful. A pure vector database, I mean, if all you want to do is just do vectors, then that might be a good choice for you. It's as simple as that, okay? I mean, that might work for you, or just using a library as well, sort of an in-memory library if you don't need the persistence. So that was one thing that came up a few times. And I think the concern as well about data in terms of sending things across the wire, that kind of thing, running things locally, those are always important considerations that we get. I think I used the thing about CUDA. So I think the Google technology is pretty flexible, runs on CPU and GPU, and whatever processors are available, it will adapt and give you. It will still work essentially. So I think that was
Awesome.
all for me, Matt. So
I like it. I like it. Okay, one more minute before we have to announce the AirPods winner. Ayush, anything else you want to address before I start that announcement?
Nope, I think we're good.
All right, good stuff. So as I mentioned during the intro, on Wednesday, we're going to be presenting, or Akmal is going to be presenting the GPT workshop, how to build fraud detection using OpenAI. I've just put that link into the chat one more time. So take a look. Hopefully we will see you there on Wednesday. The announcement you've been waiting for, today's AirPods go to Sriram Kishore Naraharasetti, Senior Software Engineer at Walmart. Congratulations. Thanks for joining. If that's not you, don't give up. We're going to announce one more AirPods winner before the end of the day to someone who has tried out Ayush's GitHub there. I've put that in the chat. I will also include it, or have I put it in the chat? I'll put it in the chat one more time here. And I will also include it in the email that we send out. Everyone that registered is going to get a copy of this video recording of this webinar and also a link to that GitHub that I just put into the chat. So try it out. Hopefully you will be our next AirPods winner. Thank you so much to Ayush and also to Akmal for joining our webinar. Thank you to our audience. Have a great rest of your day, everyone. Bye-bye.